Welcome back, ladies and gentlemen. So, we're going to take a look at our review for our test, and we'll get things rolling. Okay, so you're going to have one question on this. I have two of them on the review. I just want to give you guys two examples of it. So it says here, solve for x using your knowledge of mid-segments in a triangle. Well, what I can do is, we know the mid-segment, okay, is the line, that's the midpoint, that connects the two midpoints of two sides of my triangle. So that means this interior side is going to be half of the outside. So what we're going to do is we're going to do 2 times 2x minus 3. 2 times the inside equals the outside. Okay. If I distribute that in, 4x minus 6 equals x plus 9. Okay. And now I'm just going to solve it like I've been doing. Subtract x. 3x minus 6 equals 9. I can add 6 over. 3x equals 15. Divide by 3, x equals 5. I will give you guys a little heads up if you're listening to this video. What you're going to need to do for the test is you're going to need to substitute this back in. So whether it's solve for Q or for YW, if I plug 5 back in, 2 times 5 is 10, minus 3 is 7. 5 plus 9 is 14. So either way, we're good. Okay. Same idea over here. Just to give you guys another example of it. Here's the inside one, the x plus 2. So 2 times x plus 2 equals 3x minus 8. I can distribute that 2 in. 2x plus 4 equals 3x minus 8. I can subtract 2x from both sides. Alright, so I get 4 equals x minus 8. How do I get this x by itself? I have to add the 8 over. So x equals 12. Same idea. If I plug that in, here's 14. And here is going to end up being 28. All I did really was times 14 by 2 because I knew it was going to happen. Okay? Okay. I'm going to show you guys one of these. Okay, use coordinate geometry to prove the following triangles or isosceles, just because all it is distance formula. So I'm going to show you guys part B. All right, part A, you've got all the points labeled, but here I don't. Here's my origin, 0, 0. To find C, I go to the right one, down one. So right one's positive 1, down one's negative 1. To find B, it's right 1, up 1, 2, 3, 4, 5. So you're looking at 1, comma 5. Okay. And if I want to find A, back 1, 2, 3, 4, 5, negative 5, comma 2. You're trying to prove these triangles are isosceles. So you need to find out which two sides are the same. Looking at this picture, I'm thinking it's AC and AB. So I'm going to find the distance from A to B first. So my A is negative 5, 2. My B is 1, comma 5. That's my x1, y1, x2, y2. Guys, I will give you this formula, so you do not have to know it. Okay, so here we go. You're plugging things in. x2 minus x1. So x2, 1 minus negative 5 squared, plus y2 minus y1, 5 minus 2 squared. Don't forget the square root symbol. Minus and negative becomes plus. You guys are really good at that. So 1 plus 5 is 6. 6 squared. Plus 5 minus 2 is 3. 3 squared. We're looking at 36 plus 9. Square root of 48. Okay? Okay, so at this point, what I would like you guys to do is I would actually like you to type in your calculator square root of 48. I know we worked on in class that you could technically break this down to be root 16 times root 3, which is 4 root 3, but I would rather you guys give me a decimal approximation for right now, just to keep it pretty simple. Okay, so 6.93. Here's the thing. You are halfway done. You still need to prove that AC is equal to that. So what I'm going to do now is I'm going to write down AC, which is negative 5, 2, and C is 1, negative 1. I'm going to do the exact same thing. And guys, remember, you can use your calculators for this, okay? So we're looking at 1 minus negative 5, negative 1 minus 2 squared, okay? I know I'm writing kind of tiny. So plus, okay, 1 minus negative 5 becomes 1 plus, which is 6. Negative 1 minus 2 is negative 3. You're looking at 36 plus 9, which again is square root of 48, which breaks down to 4 root 3. But again, what am I looking for? just your decimal approximation. Quick word of advice here. If for some reason you were to find the distance from B to C and it does not equal 6.93 or it doesn't equal the other ones, you have to do the third side then. That's why I'm telling you guys to stop, look at the problem, see what it's asking, look at the picture, and figure out which two sides look the same before you do anything. It'll make your life way easier. Okay? Alright, on the back. So, you do need to know these postulates. Okay? Like, I mean, I'm going to have them written on the test, like SSS, SAS. Hopefully you guys realize it stands for side, side, side. But what does it look like? Well, here's a side. There's another side. There's a third side. We use 1, 2, and 3 tick marks to show that, hey, this side's the same as that, but this side's not the same as this side because this one's the same as that. All right, that's all it's saying. Side angle side, you've got a side. You have an angle directly next to it, and then you have a side. Your angle needs to be in between it. Okay, that's the whole kicker there. Angle, side, angle. We're looking angle, angle, side, side, and then angle again. Okay, same thing with the tick marks. See how I did 1 arc, 2 arcs? That's to show this angle is the same as that, and that, so on. Okay, AAS, you're looking at angle, angle, side, angle, angle, side. Okay, and you can look at, like, I can flip these triangles all over the place. We can get all crazy with it. It's just you're looking for the pattern. Finally, this is the last one. We talked about this a long time ago. I just want to make sure I refresh my memory because there's one question on your test about this. Hypotenuse leg. Okay. Hypotenuse leg. This is a special one. This can only happen with a right triangle. All right. And basically what it says is the hypotenuses are congruent, and so are the legs. Now, I know we talked about in class, this looks like angle side side, which you don't want, right? Because it's the one we don't have. We don't have SSA or ASS. Ha 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 ha. Jokes ensue. But if this is a right angle, we can do it because it's hypotenuse leg. So which pattern can we not use? We cannot do SSA, all right, which looks like this. Side, angle, or sorry, side, side, angle. That's the one you can't have, okay? So that one does not work. So make sure you know that. You'll see an example of that again, all right? Here, we're looking at number 5, given triangle ABC is congruent to triangle DEF. Find the values of X and Y. Guys, we're using this to our advantage. Oh, sorry about that. I'm just always so popular. People just want to talk to me all the time. So here, what this says, we're trying to find the value of X. Well, here's X. X is next to angle D. Angle D is congruent to angle A. So what I'm looking to do here is say 5x plus 2 equals angle A, which is 87. Okay, well, I'm going to solve this. Subtract 2, 5x equals 85. Divide by 5, x equals 17. Okay. Now, if you really want to, we're trying to find y then. So y is right here, which is C. C matches up with F. Oh, what's angle F? Oh, no, I don't know what angle F is. Well, if you plug in 17 over here for x, 5 times 17 plus 2, I'm going to get 87 degrees, which don't you think makes sense because they're across from each other. But if I want to find F, I know the 3 angles have to have to 180. So 42 plus 87 is 129. 180 minus 129 is 51. So I can say 3y equals 51. I can divide by 3, and y equals 17. Okay? So make sure you guys are using your congruence statements. That's a really big part. This right here is like a perfect follow-up to that. For this question, state the corresponding part if triangle ABC is congruent to triangle RPQ. Use the figures to complete each statement. All right, here's a picture. I never look at the picture, ever. I never really do. That's just me. I like looking at this because all I'm doing is playing a matching game. ACB, angle ACB, is congruent to A, C, B. 1, 3, 2. Come over here. 1, 3, 2. R, Q, P. It is that easy. Now, if you look at the picture, ACB is right here, which is the 3 marker one. So the 3 marker one down here is, again, RQP, right? Okay, so it's up to you. You use the picture, you can use this, whatever. Angle QRP, okay, QRP, 3, 1, 2, 3, 1, 2, CAB. Okay, perfect. CB, we're going 3 then 2, is congruent to QP. Okay, if you're wondering how to write the notation, just literally look over here to the left and write the same thing down. And finally, PR, BA. Okay. All right, so the second part of this test, or like the last part, you are going to get 6 questions on all of these, okay? So please look through this, ask any questions if you need to, and I'll happily help you during class, but make sure you guys are aware of the difference between side, 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 you know, and so on. I guess the only thing I really want to show you is make sure you know these 2 things. If a triangle is back to back, that means that this side is going to be congruent, okay? Strangely enough, this is that new one we talked about, right triangle, the hypotenuses are congruent, and so is a leg. That's HL, okay? But the other thing I really want you guys to make sure you're cool with is if I have triangles across from each other, these angles are going to be the same. So angle, well, I'll look up here, angle, angle, side, AAS. Okay, so please keep trying these out. We're here if you have any questions, or I'm here if you have any questions. And as always, keep the good work, good luck. We're all counting on you.